Oh,
Not
really?
as lot harder than that.
Yeah. Well, if you get the tools, it's not hard at all. All right. This is another war story. Everybody watch now, okay? Everybody watch. Okay, so what we have here, usually whenever you put something in there, you know, one of the cool things about whenever we changed out the engine in that 06 F-150, that 06 Silverado, was it had a 4.8, and we put a 5.3 in it, and it was plug and play. We didn't have to change anything. We just put it in there, bolted it up. You know, pretty cool. A lot of the times when you're going up with an engine size or something like that, you know, you have some stuff that's not quite the same and all. And this one here, we figured it's going to be a plug and play deal. All right, so if you get a used engine with a unit from a different year model, that's one of the fastest ways to get up close and personal with just about any job. Okay, so this Cavalier belonged to a young woman with a little bit of savvy when it came, or very little when it came to maintaining her vehicle, and now she understands a little better than before. She discovered it's not a good idea to ignore an overheating problem, even if the car appears to be running well most of the time. And so, you know, a lot of times people will just keep on driving them. And there was a funny little blurb I put on my technical writer page where this, this guy says, I was driving my car and it just quit. And the mechanic says, how far did you drive it? And he says, till it quit. You know, basically want to know how long you were driving it before it quit. And they just said, okay, so we got this 97 Chevrolet Cavalier, 88,000 miles, 2.2 liter engine, 3T40E transaxle engine, overheated to the point of destructive meltdown. This is a big problem, right? All right, so we push in some coolant. So the water pump has been replaced, but the engine was hydro-locked when we tried to spin it over. You're going to spin it over, boom, it just stops. Right. Okay, removing the spark plugs, we had a number 2 cylinder. It was filled to the brim with coolant or water. Out on the service light, bumping the engine blew the coolant out of that hole, but when you added coolant to it, it just filled that hole right back up. That's not really hard to determine at that point that they have got a serious problem. You know, blown head gasket at the very least, cracked head, maybe even warp block, whatever. All right, so it had been overheated to the point that putting the head gasket on it would only serve to be a waste of time, because a lot of the times, and I've seen shops do this, a lot of times they'll say, well, and I'll tell you something else that places do, is they'll just off the cuff say, blown head gasket, blown head gasket. They don't even troubleshoot anything. Now sometimes, like this case, you can tell, yeah, it's a blown head gasket, that's all it can be. But sometimes just because one's getting hot and they don't know why, they'll say, blown head gasket, without even troubleshooting anything. A bunch of ways head gaskets can blow, you know. And so anyway, even if the head wasn't warped, it was likely the rings had lost their tension. I've seen them where people would put a head gasket on it and then the thing's burning oil, something awful, because the rings got hot enough to where they lost a lot of their tension. You basically didn't have anything going on there. So the salvage yard brought me an engine for $550. That's not too bad, is it? Well, 2.2, they brought it over here for $550. Now Johnny, he owned a salvage yard. He said he could strip one of these 2.2s down to a long block and sell it for $750 to somebody that needs an engine for an S10. Same motor. You just strip it down. It got different manifolds and all that kind of stuff. And he said he could get $750 if you're putting it in an S10, but if you're putting it in a car, you can only get about $550 for it, in spite of the fact that it's the same engine. Okay. Somebody needs parts, $550 is about all you can get for a 2.2. Now, Victor was working on it. One of the guys named Victor I had working here. Disconnected everything, dropped the H-frame, lowered the whole powertrain out the bottom like we do. The replacement engine got a rear main engine oil seal, and the 3T40E got a torque converter cell while we were in there. Now, one of the things I like to do when we're putting a salvage yard engine in there is I like to take a look at the timing belt. I like to take a look at the water pump. Of course, this one had a new water pump on it. And I also like to look in there, if it's not too much trouble to look into the innards of the engine. I want to see if it's got a lot of sludge in it. Now that sludge may look like it's gonna be just fine sitting there, but sometimes whenever it's been sludged up and Grandma and Grandpa's drove it to the store and back a lot, and that sludge is all over everything. When you drive it on a long trip the first time, that sludge turns into jelly and it gets down to the bottom of the pan, clogs up the screen, starves it for oil, and then all of a sudden you're locked up sitting side the road somewhere. So if there's a lot of sludge in there, that's another thing that needs to be considered. But always look at your seals, your water pump, see if there's anything like, look at all your expansion plugs. You may have freeze plugs on there that are just about rusted through. And it's a good idea, since they're easy to get to while the engine's sitting there waiting to get put in, just go ahead and pop you some new freeze plugs in it if those look like they're about to rot out. Now sometimes you can't tell until, because the rotting's on the inside, but if you can tell, you know, here we go. All right, the new water pump, somebody had replaced on the original engine. We pulled it off and we put it on the one that we have. I mean, if it's already got a new water pump on it, everything's okay with that one, just go ahead and put it in there. We put a new water pump gasket and a new thermostat. So we're starting out from scratch. We're going to try to make sure that you don't have any more trouble with this thing. So the crank position sensor was a variable reluctance $10 2-wire sensor on the 97, and the one on the engine he was installing turned out was a Hall Effect $100 3-wire sensor. Also, the oil pressure sending unit had a different number of pins, and so this is not going to plug in. But it turned out the replacement was a 2.2 from a 96 model, so this is a year older, right? Is this subject to be a problem?
Could be.
Probably not.
Yeah. How does the salvage yard people know what fits what? I mean, I have people sometimes sending me emails to my website, say, will this particular motor fit this particular car? What do you tell somebody? To begin with, if you haven't done that, you don't know. And so well, what if somebody was saying, I want to take my whatever kind of car, like my Camaro with a 2.8 in it, and put a 350 in it? What kind of advice do you give that person? If you don't have a donor car that's got the brackets and mounts and all the stuff that you need to put a 350 in that car, just be prepared to run into a lot of trouble and have to buy a lot of stuff. Because you don't just take a 2.8 out and throw a 350 where it was without changing some things, right? But anyway, but you look at this, look at these sensors. See that? See how much difference they look?
Mm-hmm.
Totally different sensors. You see that one over there is your Hall Effect. Now the Hall Effect sensor puts out what kind of a signal? Who remembers? What's the difference between a variable reluctance sensor and a Hall Effect sensor?
It one like waves and the other one like, I don't remember.
Like block, is it like block you're thinking about?
Yeah, you're thinking about digital. One of them's digital, got square waves, and the other one, well, like on that, the thing that you in that Quincy's car, it's got Hall Effect sensors on it. But those, and they're 3-wire sensors, if you remember looking at the schematic, and they're going to give you a square wave signal. That's usually what things are putting out now, but sometimes, you know, oddly enough, this one here, the 96 had the square wave type Hall Effect, and the 97 had the variable reluctance sensor. Now, I will tell you that occasionally, in the ABS world, you'll run into a sensor that's a 2-wire sensor and it'll be Hall Effect. So don't assume just because it's only got 2 wires that is a variable reluctance sensor. The variable reluctance sensor is going to give you a square wave, a sort of a sine wave thing. All right. So one question arose was, why are the 2 sensors different? There were other significant changes besides the number of connector pins we had figured out. We thought it was a plug-and-play deal. We figured it would be, but it turned out that it wasn't that. It was starting to turn nasty. So what are we going to run into here that's going to cause us a bunch of extra work? if the crank sensor reads the reluctor wheel in the center of the crank, and since these two sensors were different types from 96 to 97, would this engine even work in this car? I mean, we don't know, really. But about going back to my original question about how does the salvage yard know what fits what, is they have an interchange guide. And say, man, goodness, I would love to have access to that interchange guide. Well, you don't want to pay what the salvage yard has to pay every year to have access to that interchange guide database, because it's real expensive. But what I tell people that email me is I say, call a salvage yard, ask them. And if you got to talk to a nice guy at the salvage yard, he'll pull up his interchange guide and just give you the information you're looking for right there. I don't know that stuff. I don't have all this stuff memorized. You know, somebody asked me, you know, will this fit that? Can I put this engine in that particular car and all that? Well, this engine in that one. And I have had people that come and say, well, I've got, you know, there'll be two cars that are sort of like a clone of one another from different manufacturers. Like, well, this one here is such and such a car, and this other one is basically the same car, but it's got a Chevrolet nameplate on it. And I've got one of these with a transmission and a transfer case I want to put in this one, and you know, I've been told that it will fit. Well, you know, whenever I get to digging, you know, I call the salvage yard and say, will this fit that? And I say, no, not that year model. It won't work. You got to go forward to this year, you know, and I've called back and said, this is not going to happen. You know, then they get mad because I'm not willing to just dive in there and get in trouble. You know, be really careful about that kind of thing, because you will. All right. A little research revealed, though, that the crankshaft was the same on both vehicles because the part number was the same. That's one way you can tell. You can call and say, I need a part number. I need to know if the part number for the crankshaft on a 96 and a 97 is the same part number, because if it is, you're okay. Now, on the 98 model, it's basically the notches on that reluctor wheel are a little bit out of phase. So they're not interchangeable. You can't go back and forth with those, you know what I mean? All right, so anyway, Victor removed the 3-wire sensor from the 96 engine, walked over to the engine shop where he had pulled the plastic 2-wire sensor, and he installed the brass 3-wire crank sensor in the junk 97 engine, and it slid in there just fine. Well, I mean, you know, we were concerned about the spacing. Did you notice how those things look different? Mm-hmm. Would this sensor not reach maybe close enough to where it was going to work and all? All right, so the ignition systems on these units turned out to be totally different in the way that they were wired and the way they worked. So what was the difference? All right, now, this right here is the 96 Cavalier ignition system. These are Hall effect sensors, right? That crank position sensor, cam position sensor. All right, where do these signals go?
To PCM?
Yep, they're going down here to the powertrain control module. All right, this one here, cam position sensor signal, crank position sensor signal. And then right here, your ignition control module is basically getting its marching orders from the PCM. They look simple enough. You know, you got fuse right here, feeding that ignition module and all that. You get her going?
Nah.
Do you need a starter?
Yeah.
What kind of vehicle is it?
It's a GMC Savannah.
Okay. She need help or she goes, huh?
She said she's calling somebody to come get her.
That's fine. All right, no problem. We found out what was going on. But anyway, look at that. You got a knock sensor down here also talking to that. So that's what does a knock sensor do?
Text knock, and then when it
You mean like if it got a rod knocking?
hit that or fuel ping or something like that, and it'll return the.
It retards the time and to stop it from fuel pinging. You were right that part. But as far as an engine knock, it ain't gonna pay no mind to that because it's only looking at it in a narrow range. But anyway, never mind. Now this right here is a 97. What's the difference?
Well, crank position sensor and the cam position sensor, well, they're not specifically speaking to the PCM.
Yeah, let's back up. That's the 96.
Mm-hmm.
That's the 97.
Mm-hmm.
Back up one more time.
Crank position sensor is talking to the ignition
Does
control
one have
module.
a distributor?
No.
I thought maybe that's what that little,
No, they're all full. I mean, they're all full pack. Ignition control module is receiving its information. It's a variable reluctance sensor. You notice how that's drawn directly from the crank sensor to here. And then this right here provides, I mean, it actually aligns and defines that signal and sends it on down here, which it uses it for fuel injector pulse and all that. The camshaft position sensor remains a Hall effect unit, and so basically you're going to have a square wave coming off of this. Now this right here, in a lot of cases, when this sensor goes here, and some of these, and I didn't scope this one so I don't know, a lot of times this module right here will change that into a square wave signal and feed it in right here. But it's basically been converted from one of these to a square wave down there. I can't honestly say that's what's going on here, but you notice how similar it looks. You still got a fuse feeding the ignition module, but you got more wires going to the ignition module on that one you do the other one. Alright, so the 96 and 97 engines had different ignition modules, wire harnesses, different PCMs, but not surprising, the 96 module wouldn't have worked on the 97 model car even if we wanted to try to change some of the electronics. Alright, so we kept trying to stick that thing in there, couldn't get the sensor to go. With the transaxle in place, it was difficult to determine what the problem was. Well, this was a 96 instead of a 97 engine, and that led to an important question, you know, basically. Let's back up here for a second. We're going to digress for just a bit. I knew of a 1987 Jeep Cherokee 4-liter that ran just fine for about the first 10,000 miles. One day, when the owner crossed a railroad track, the engine stalled and never started again.
Crank position sensor came out.
Well, it was more complicated than that. It would snort and backfire while you were spinning, but that was it. Nothing the dealer replaced made any difference. The field service engineers were without a clue as to what the problem was. Now this was at a Jeep dealer where the guy had grandfathered in as a Jeep dealer, and he had an old shop with a wooden floor in there, and he had big doors that opened up, and he would buy one Jeep and he would sell that one, and then he would get another Jeep and he'd sell that one. He was actually a Jeep dealer, but until he decided to close up. He was the one, he kind of thought he knew what was wrong with it, but he couldn't get it repair authorization to go as far as he wanted to go. Now this right here, on the 87 to 90 Jeep Cherokees, they basically had this Bendix fuel injection system, and there was a module over there that had a little coil sitting on it, had a distributor on there, and that little module would receive a positive pulse from the PCM, which engine control module, based on the crank sensor signal that's coming off this thing here. You might notice you got these big wide windows in 3 places, right?
Mm-hmm.
All right, now that flywheel there is busted, but I just wanted to show you this ring. Okay, so it's basically using these to determine, every time it sees one of these go past, it knows one of the cylinders is like, you know, just past top dead, it's like 90 degrees from top dead center. All right, now this one right here is the manual transmission flywheel. It's pretty robust. You see, it's the same kind of deal,
Mm-hmm.
except it's got, you know, these big old heavy teeth on there because it's a manual transmission. But you notice You only can see one of them here, but there's actually, you know, anytime you're working with a 6-cylinder engine, you're every 120 degrees is where your thing's gonna be. Well, on automatic transmission 4-liter units, a lot of small windows separated from each other by really narrow metal vanes, and at 120 degree intervals throughout the circle, it's got a wide window and a wide vane. When it sees a wide window, it knows the cylinder is 90 degrees before top dead center. It uses a sync signal from the cam sensor in the distributor to determine which cylinder is coming up. It's not very complicated. If the sync signal fails, and sometimes it does, which is the one coming from the cam sensor, then the engine controller will pick a cylinder at random on startup, and sometimes it might start better than others, but it will start, right? This is how it's wired up. Now, memorize all of these pin numbers and how that's done, because I'm going to give you just the blank and have you draw it, and it has to be right, okay? All right, you got that? Got it. Everybody burn that in, right? What's this right here? Can you look at it and tell?
Looks like a relay.
That's the starter.
Oh,
What are these?
fuel injectors,
What's that?
ignition module.
That's the ignition module and coils made together. Fuel pump relay, power latch relay. There's your engine controller with all that stuff. This was made by Bendix. Pretty tough, by the way. That thing is about bulletproof. I've seen injectors get dead short and the injector line will go to sleep, but you could basically let that thing cool off and it'd pick up and start firing again. Pretty darn tough. All right. Finally, AMC Jeep bought the vehicle back, and sometime later when the engine was removed, one of the engineers noticed two things. A nut fell out of the bell housing as the engine and transmission were separated, and the nut had left its signature on the crankshaft pulse ring, which had a lot of narrow slots and 3 wide ones. So what happened was, when that nut jumped up, when the guy hit the railroad track and it got trapped in there and bent one of those in, it basically thought it saw an extra wide window it didn't know what to do with. You got me? That's what was wrong with the Jeep. The divider between 2 of the narrow slots had been dinged in. Crank sensor read 2 narrow slots as well as 1 wide slot. It was, you know, as 1 wide slot rather, and that didn't make any sense. So the PCM was firing the coil erratically because it saw 4 wide slots instead of 3. The bump over the railroad track had created the wide window, and that nut had laid there for 10,000 miles. Wow, somebody really slammed that hard. All right, the 1997 sensor on this one here that we were working on wouldn't go in there. So we lubed and we twisted and we pushed and we even sanded on it some. We felt a hole and everything else we could think of. Really should have gone in, but it just wouldn't. And I didn't care nothing about buying another sensor just to see if a new one would go in there. If the obstacle was a layer of varnish, it was too thin to feel with the naked finger, so we just couldn't see that final rise in the way, and it's hard to tell. So we called them. We muddied the water. The interchange book said the 96 engine had a 2-wire sensor and the 97 engine had a 3-wire sensor, which was backwards to what we were experiencing here. And we noted with some interest that the 97 sensor slid into the 96 engine block. Was it possible the swap would work in one direction but not the other? You know, if you got one hole that's a little bigger, the sensor will go in there. Both sensors will go in that one, but all the one will go in the other one if you get where I'm going. It would seem that way. So the salvage yard guy said he'd never run into this problem before. But he's going to bring us the 97 engine anyway and strip the first engine for an S10 long block seal, and that's what he did. Well, with the first replacement engine back out of the car and on the floor and more accessible, we inspected the 96 block's crank sensor hole, revealed a port that should have accepted the 97 sensors. Well, this looks like it ought to go in there. Felt smooth, but we couldn't get that sensor to go into that hole. The salvage yard guy, he tried to stick it in there too and it wouldn't go in. So anyway, we reinstalled the old sensor and he presented us with the 97 engine exactly like the one we were moving originally. We got the engine in, we got it running, What do we need to do now? What do we need to do now? There's a step that we need to do in a situation like this that I've talked about before. So what do we need to do?
What
Drive
happens
the
if the
car,
problem
see if
is?
the problem reoccurs.
Check the PCM to see if it's doing what it's supposed to.
I'd
Check
say
your crank
drive.
signal.
I'd say drive a car because you need to see if it's gonna run hot again.
That's a good thing, but before I do that, of course, you know, when we burp it out and all that kind of stuff, I always like the fan to kick on and off and all that. But is it possible the fan could kick on and off, but still have a problem?
Maybe take the fan and unplug it and spin it through and check and see if it's got a dead spot in it.
Yeah, which is what we were talking about doing right there. But you can also take your engine coolant temperature sensor out of the loop. You can hook a, hey girl,
Oh, you're in class?
yeah,
Okay, can I ride with you?
Yeah.
Okay.
50K pot. And this is, you take a 50,000 ohm homemade coolant fan tool, potentiometer, I got one of those that I built in there, and you put that in there. With the engine running, you can dial in whatever temperature you're looking for, but you kind of need to know where it's supposed to come on. Where do you think the coolant fan is supposed to kick in on a Cavalier like this?
About 120,
Huh?
about 120, 115.
210.
Anybody else got any numbers you want to throw around?
Yeah, I'm thinking somewhere around.
185.
228.
228.
That's pretty scary, isn't it? 228 degrees is when that thing's supposed to come in. So what you do is you take your scan tool, you hook this tool up, you turn it to where the tool is reading 228 degrees, you see if the fan will kick on. Ooh. If it will, you know the PCM can turn it on. You can also, if you got a two-way talking scan tool and your model's right, you can basically tell it to turn on the fan in some cases. You can't do that on every vehicle, but you can, you know, if you can, you can. But I like to trick it. I like for the PCM to turn it on as it sees the thing. You remember the one I told you about the other day that wouldn't turn on the fan that was in a previous session and absolutely would let the engine melt down before it ever turned on the fan, and it turned out it had a bad body computer? All right, anyway, and the body computer, you didn't think, this is what Jonathan was talking about. You take a light, you hook it in series with the motor, you turn the fan motor through. If that light ever goes out, that motor's bad. That's a go, no go test. All right. All right. So, tell me something you learned. Tell me something you didn't know, you know now that you didn't know when you came in here.
96 and 97 motor or 97.
Yeah. But you know how to check a fan, right? Two ways to check a fan. What?
Oh no, I was gonna just say, just because it says it's compatible doesn't mean it's always gonna be compatible.
Yeah, the interchange guy's not always right.
Yeah.
Now, usually it is. I mean, so I'm not trying to give the interchange guy a bad rap, but a lot of that has just basically been put in there by people that have tried it to see what would work, versus really is, that's kind of like the oldest version of, you know, information sharing out there, because they've had interchange guides at junkyards as long as I can remember. You know, they used to have them in big old books that they'd pull down and flip over. Some of them would say, well, the door panel on a 69 LTD fit a 70 model LTD. And they'd say, basically, the door panel will fit, but the window crank handle's in the wrong place, or something like that. Now, how do you remember, I may ask you this before, back in the 70s, do you remember
Nope.
if you looked into, well, I mean, if you ever seen that, before they went to this 17-digit serial number, how could you tell what your model car you were working on if you weren't sure?
Taillights, headlights.
Yeah, they actually had pictures in the book. I mean, like in the shop manual, you'd flip open the front page of the book. It covered like, 68 to 73, and it would basically show you pictures of the front of the car in the book, so you could look at that picture and say, yeah, that's what I got right there. That's the way they did that back then, because the serial number was just a wild card and it was all over the place, you know. If you knew on a Volkswagen Beetle, the third digit was, if it was a 113, it was a 63 or a 73. You know what I mean? You could, if you can't tell the difference between a 63 or a 73, you got problems anyway. You know, you don't need to be working on a car and all that. But anyway, so I just wanted to share that little story with you.